Hello students, in AI Unit 3 Knowledge Representation. In this Unit 3 previous video lecture, I will start the topic resolution. In this topic, first I will explain the definition of resolution, then its basic introduction is completed with example. Now another topic in resolution, conversion to class form. We can convert the resolution into class form. So here the basic introduction is completed in the previous video lecture. Now today I will start the algorithm for convert to class form. Okay. So in this algorithm, first we can eliminate the comma, okay, using the fact that A to B is equivalent. So not A or B. We can say that A to B is equivalent to not A or B. Okay, then we can performing this transformation on the valve form formula given above becomes. In above example, we can take the different sentences. Okay, so here we can perform the transformation for all x, not Roman x, and no x comma Marcus. This is the one sentence. Marcus was a man and it is Roman, or had x comma Caesar, or for every y not there exists z, had y comma z, or think crazy x comma y. In this first step, different symbols are used. This symbol for and, this for all, this symbol, and there exists, this symbol is used. Okay. So this is the first step. Now the second step, reduce the scope of each not to a single term using the fact that not P is equal to P. In maths you can learn equal means equal. So same not is equal to simple P. Okay, then it is performing this transformation on the valve form formula from the step 1. From the first step, we can say that for all x, not Roman x, or not no x comma Marcus, or had x comma Caesar, or for all y, all z, not had y comma z, or think crazy x comma y. So what is the difference between first and second step? Okay, you can see in first step we can make the first whole sentence with not sign. Okay, and here we can use the not sign between two different attributes. Then we can take for all. Okay, this is the difference between first step and second step. Now the third step, standardize variable so that each quantifier binds a unique variable. Since variables are just dummy name, this process cannot affect the truth value of the valve form formula. Here we can use the standardized variable, and we can make the unique variable, means that variable are not same with another variable. Okay, so we can take the dummy names and we can find out the truth table for that unique variables. For example, the formula for all x p of x or for all x q of x would be converted to for all x p of x or for all y q of y. First sentence is for x and second is for y. So here we can take the two different variables x and y and make the equation like this. Okay. Now step number 4, move all quantifiers to the left of the formula without changing their relative order. This is possible since there is no conflict among variable names. And performing this operation on the formula of step number 2. Now we can make the formula without changing the variable order. So we can write the equation from the step number 2 for all x, all y and all z not Roman x or no x comma Marcus or had x comma Caesar or not had x y comma z or think crazy x comma y. This step will be written like this. Okay, this is the difference between step 2 and step 4. Okay, the order will same, but we can change the variable by our use. Okay. Now step number 5, eliminate existential quantifiers. So for example, the formula there exists y, this is the symbol of there exists. Okay, there exists precedent y can be transformed into the formula. It is the equation and we can convert the equation into formula. So we can write the precedent in bracket S1. Okay, for example, in the formula for all x there exists y father of y comma x. So here we can write that for every x there exists y, precedent is someone father. So we can write the formula like this and then would be transformed into for all x father of h2 x comma x, like this. Okay, these generated functions are called column functions. Sometimes ones with no arguments are called column constants. This function is known as column function and sometimes the argument is known as column constants. Okay. Now step number 6 is drop the prefix. At this point all remaining variables are universally quantifier. So here we can prefix and just drop the variable and prove the procedure. So we can simply assume that any variable it seems is universally quantified. Now the formula is written from the step number 4, not Roman x or no x comma Marcus or hat x comma Caesar or not hat y comma hat or think crazy x comma y. From the step 2 we can write the step number 4, and from the step number 4 we can write the step number 6. Okay, now our step number 7 is we can convert the matrix into a conjunction of disjuncts. In the case or our example, there is no and symbol is used, we can use only or operation. Okay, so here we can use the match property, associative property. Okay, for equation A and B or C is equal to A or C and B and C. Okay, so we can simply remove the parentheses. This square parenthesis is removed. Not Roman x or not no x comma Marcus or hat x comma Caesar or not hat y comma z or think crazy x comma y. Here we can remove square parenthesis and circle parenthesis in this step number 7. Step number 8, we can create the separate classes corresponding to each conjunction. Okay, so here we can use the well form formula, and if it is true, then all classes that are generated from it must be true. Okay, now this step number 9, we can use the standardized part variables in the set of classes, and it is generated in the step number 8. So here we can rename the variables so that no two classes make reference to the same variable. So our transformation will be written like this: for all x where p of x and q of x is equal to for all x p of x or for all x q of x. In maths you can learn this equation. So this equation we will use in the AI concept. Okay, and written like this. Now each class is separate conjunct, and since all the variables are universally quantified, there need be no relationship between the variables of two classes. Variables are independent, so classes are also independent. Okay, so they are generated from the same well form formula. So here our algorithm is completed. Now I revise the topic. In the previous video lecture, I will start the topic resolution, its definition, basic explanation is completed with example, and we can start the topic conversion to class form. In this topic, the algorithm is given for convert to class form. In this algorithm, different 9 steps are given. So today I will explain all 1 to 9 steps in details. Okay, and in this 9 step we can use the simple sentence, and that sentence converted into functions, and the functions converted into formulas. Okay, now next lecture I will start the algorithm for propositional resolution. Okay, thank you.